Thank you for joining our webinar today, AV over IP, Understanding the Basics. My name is Carrie Olenek. I'm the Marketing Director here for ZeeVee. I'm pleased to introduce our two speakers for today, Matt Dodd, Training Consultant for the Clavia Group, and Rob Moneyman, the EMEA Sales Director for ZeeVee. Both Matt and Rob have been instrumental to the success of our in-person AV over IP technical training programs because of their vast knowledge of the AV industry and understanding of IP networks. As a way to bring our training to more individuals, we've developed a series of educational webinars. Although leveraging standardized hardware and software platforms for distributing AV over Ethernet is by far a more simplistic approach to moving content, a basic knowledge and understanding is essential to successfully deploy IP solutions. The main goal of this webinar today is to introduce you to the OSI 7-layer model. I'm going to hand it over to Matt right now, and he can go into more specific detail about what you'll be learning today on the webinar.
Yeah, thanks, Kerry. Here's what we're going to be looking at over the next hour or so throughout the webinar. First things first, when we talk about networking, we need to have a much better grasp on how a data packet actually moves from one host to another host across a network. And indeed, either that can be either in a private network inside somebody's home, or it can be out there in the World Wide Web. And when we talk about hosts, we talk about a device on a network. So that's the first thing we need to really agree on, terminology and how the data packet moves from host to host. We're going to be looking at the importance of deploying the correct equipment for the correct job. There are cheaper pieces of kit out there which we can use, which will do a very simplistic networking job for us, right up to really quite sophisticated and much more expensive equipment to do a much bigger job. So having a clearer understanding on the right equipment for the right job is extremely important. We'll be taking a look at the sets of rules that video over IP uses to work properly. And as we'll explain very shortly, video over IP really is coming to the fore when it comes to distributing video. We'll also look at why it's very important to have a solid grasp of the OSI 7-layer model. The Open Systems Interconnection model is now pretty much the de facto model which we use to describe and explain and use networking across a large scale area. Whereas beforehand we used to have many different types of networks, now we tend to just focus on the one. So understanding how that works and the model will really put us in a good position for explaining networking to others and for understanding and deploying our own networks. So I'm going to hand over to Rob now, who's going to talk to you a little bit more about ZeeVee and ZeeVee's role in video over IP.
Thank you, Matt. Yes, so before we get into the meat of the presentation, I'd like to give you a little overview of ZeeVee, a background of ZeeVee, and a little bit about our approach to AV over IP and the product sets that we have as solutions for that. So ZeeVee actually has been around for over 10 years, and our key competency in that time has always been video encoding. Initially that was developing solutions to send video over a standard infrastructure that existed in many facilities in the US, and that was coax. And actually we have many installs in sports bars, stadiums, places of worship, etc. in the US, simply because coax was an infrastructure in place, and if it's there, why not use it? About 3 years ago we opened an office in Europe, and although the market for video over RF isn't quite as big and strong as it is in the US, we have found a number of niche areas where it fits absolutely perfect. So again, stadiums, and instead of sports bars, it's pub chains and retail betting shops, applications like that. So moving video over RF is quite an easy solution and eloquent solution. About 5 years ago, we actually embarked on development of the same type of encoding, video encoding, but putting it over IP. And again, this time the standard infrastructure would be Ethernet. But it really doesn't matter whether our solution is AV over RF or AV over IP. One thing that ZeeVee does strive to achieve is to simplify the solution to make it as easy as possible for you, the integrator, etc. One other thing I'd like to make you aware of, because AV over IP has been around for some time, ZeeVee has actually formed part of an alliance with 5 other companies, and that's called SDVoE. I won't go into the details of this now. It actually stands for Software Defined Video over Ethernet, and the other founding members are ZeeVee, Sony, Christie, Aptivision, the chip manufacturer, and Netgear. And the idea is to drive towards making SDVoE a standard for video over IP. Actually, ZeeVee is now on the 3rd generation of IP-based products. So we've picked up a lot of knowledge and experience in that time. Moving on. The fact that you've joined this presentation is great, because you've realized that something is happening, and that's AV is moving to IP. We used to talk about it as something that would happen in the future, but really it's happening right now. And the actual market for AV signal distribution is worth over $8 billion. So currently all of that's done with proprietary technology. So many manufacturers involved there. Each of the manufacturers producing switches which are proprietary and not compatible with each other, which is a little bit odd. But all that's going to change. The technology is going to run over in the future will be Ethernet, and cost of Ethernet switches is coming down all the time. The cost of bandwidth is all coming down, and it means that we're going to have this standardization. So everything is going to run on an Ethernet technology. There's lots of advantages to that. Moving on. And the advantages of AV over IP are, well, number one, it can be a single platform for IT and AV. You could actually keep the AV as a separate switch to your IT if you want, but no reason why it can't sit on the same network as your IT. It would mean that you can do away with all of this specialized training and proprietary technology that you need to have at the moment if you're going to install that type of solution. It's now, get trained on one thing, and that's Ethernet. And as I said earlier, Matt's going to kick that off today, hopefully. It means that there's, you don't have to learn how to program proprietary technology. It's just configuration. But above all, it means that you've got a scalable, flexible solution that sits on a standard piece of architecture, and the limitations really start to disappear. Moving on. Now, AV over IP means many things to many people, but there's always this trade-off between bandwidth, image quality, and latency. If you've got lots and lots of bandwidth, you can have the best image quality, and you can have very, very low latency or zero latency. By latency, I mean the delay between the original video source and it appearing onto the screen where you want to look at it. So, for example, if you had an application that was retail signage, it probably wouldn't matter if you had some latency there of half a second, quarter of a second, whatever. It really wouldn't matter. On the other hand, if the application was something in an operating room, so a medical application where you had a surgeon and he's looking at a screen and he's got his scalpel and he's about to make a cut, then I'm pretty damn sure that latency would be important, as would image quality, and you'd expect the image quality to be pixel for pixel perfect in that case. But of course, if you've got a high image quality and low latency, it means that you need high bandwidth. Again, as I said earlier, that's becoming less and less of an issue now going forward, because the cost of bandwidth is coming down all the time. Next slide. So ZeeVee's approach to this is not a one product fits all solution. We've got solutions which are applicable to different types of applications. So Zyper HD is a solution which is heavily compressed. It'll work on a 1 gig network, but because you're using compression, there will be latency. For something like digital signage or moving video around where latency isn't an issue, it's absolutely perfect. Right the way to the top, Zyper 4K at the top of the chain there, which is an uncompressed solution, zero latency, pixel for pixel, which really gives you the best performance of all. And when you think about it at the moment, actually, the solutions that are being run over proprietary solutions are in fact uncompressed and pixel for pixel. So Zyper 4K gives you an instant replacement for that. It does need a 10 gig network, as I mentioned, but cost of network switches is coming down. For example, a 48 port network switch now from Netgear, the list price of that is less than $4,500. So rapidly coming down. So that's my little overview of ZeeVee and the product sets that we have. At this point, I'm going to hand over to Matt, and he'll start off on the journey to AV over IP by going through the OSI model. Matt.
Thanks, Rob. Yes, so Rob's just given us a really clear overview as to how quickly video is moving over the IP framework, as opposed to the proprietary matrices that we're used to seeing in the past. Certainly for smaller systems, we're still going to see a lot of the matrix type video distribution. But as systems grow in size, certainly for commercial development on projects, we will see a number of sources being displayed across many screens, even across multiple buildings. And the only real way that we're going to be able to service that is by doing by sending that video over an IP framework. An IP, as Rob certainly alluded to, is fast becoming the norm. More and more devices are appearing on a network. Those devices, in terminology cases, you can see on the screen, we call a host or a node. So there are more and more hosts appearing on networks. We used to have the traditional computer, printer, then the mobile phone took over, and then we've got laptops, we've got various different electronic gadgets appearing on our network. But of course now we've got microwaves, we've got fridges, fridge freezers, we've got baby monitors, we've even got air fans. The Dyson air fan that sits on your desk is now Wi-Fi enabled. Although why you want your desk fan to be Wi-Fi enabled is beyond me, but hey ho, it just proves that there are more and more hosts appearing on a network, and we have to follow suit with that. And what better way to put video across a large scale than to do it over IP? So you'll see on the screen there some of the terminology that I'm going to be using: the host or a node, which is a device on a network, or more specifically a NIC on a network, a network interface controller. And then we've got the NIC itself. So what is the network interface controller? Well, let's consider this to be the physical network card. If you've ever pulled apart a PC, a tower PC before, and you'll take the side off, and you'll see that there are a number of cards slotted into the motherboard at the back. One of these could well be the network card, which you would plug your network cable into, and that card will be what we class as the NIC. It's the physical network card, which we would then attach the physical cable to, be it optic fiber or be it a copper cable. It could also indeed be an RF NIC. It could have a little aerial popping out the back of it, and that enables us to connect it to a wireless network. Finally, the last bit of terminology I want to use just for this webinar is protocol. And the definition of a protocol is indeed a set of rules. And in this case, it's a set of rules pertaining to how a data packet will behave at each layer of the OSI model. And we'll look at that in more detail shortly. Yeah, you may have heard the word protocol used in all sorts of instances as well, certainly on films. That's against protocol, sir. It's against the sets of rules. My apologies, there for the mediocre American accent, but hey, at least I gave it a go. Whilst I'm moving to the next slide, feel free to practice your British accent. So here you are. This is you with your mobile device, and you are invariably going to use your smart device, smartphone, in this instance, to you're opening up an app, you're opening up applications. So let's put this in a real context. You take out your phone and you're going to get the Facebook homepage. You want Facebook to appear on your phone. So your phone is, of course, a what on a network? Correct. 10 points to all of you that said a host. It is indeed, and that host is being used by you. And here's what's going to happen. We're going to see just how that packet of data moves from that host to another across a network. Now, bear in mind that we're just showing you here the basis of how a network works, but it's no different if the host was indeed a video encoder, which is then going to stream data packets, in that case video data packets, across a network to a decoder, where it will then be shown on a screen somewhere else. No difference whether we're capturing the homepage of Facebook or we're trying to stream video, whatever else we want to do on our network, it's no different. These rules still apply. So here's what we're going to do. We're going to introduce you here slowly to the OSI 7-layer model, and there they are, all 7 layers. Now this is an ethereal model. You can't be sent an OSI 7-layer model by Amazon. You can't open a box and see 7 layers sat there at the bottom of the box. It doesn't work that way, of course. It's an ethereal model, but each of these layers is effectively contains what we call protocols. As we already discussed, those protocols are sets of rules. Now, anybody that comes along to our proper training, face-to-face training, we explore these rules in more details, and there are literally dozens and dozens and dozens of these rules at each various layer. And in fact, if you check on Wikipedia and put in the OSI 7-layer model, you will see all of the different rules at various layers. And you'll notice that a lot of these rules end in the letter P. No guesses for what that stands for, of course. It's protocol. So we've got some popular rules in there that we may have heard of before. DHCP, Dynamic Host Configuration Protocol, live at layer 7 there. And Post Office Protocol also at layer 7. We've got the world famous IP, Internet Protocol, down there at layer 3. And what's quite good about the OSI model is it's giving us a model which we can use as a framework for all of the terminology that we ever discuss within networking. That's quite good, really, because we're going to see how the data packet moves from you right at the top there with your Facebook on your phone. How does that data packet get from there to, say, the Facebook's home server, wherever they are across the other side of the world? How does it get there and back? We're not going to concern ourselves with how it does it so quickly, because that would just blow our minds. But let's just think about how that data packet moves. So first thing we need to do is introduce the data packet. There he is, and that data packet has come from you in your application at the top of the tree there. Now again, during the one-day training, we will spend more time discussing what these layers mean, but for now, let's just take a look at the overview. How does that data packet get from one host to the next? Well, it travels downwards. It's the only way it can travel from here. It goes from layer 7 right through to layer 6 to layer 5 and so on and so forth. And as it moves down through the OSI model of the host, which in this case is your phone, so this is your mobile phone's OSI 7-layer model. As it moves down the 7-layer model from 7 through 1, you'll see that it's collecting these headers of information. So it's collecting all the rules that are applicable at, in this case, layer 7. And when it's done that, it moves down to the next layer, layer 6. And you'll see there that the rules are applied that are relevant to layer 6. And these first 3 layers, layers 7 through 5, these are really the software engineering layers. So the people who write the application will determine which rules this data packet needs to collect at these 3 layers. So now we've got the headers for the layer 7, 6, and 5. We're going to keep going down, and the data packet is going to collect another set of rules in another header. This time it's for the transport layer. And transport through physical, so 4, 3, 2, and 1. These headers, these layers, apologies, these layers are really sort of the network engineering layers. So these are the layers that we would spend more time with when we sit there face to face in our training. We really get to grips with what these layers do. We pull them apart, we look at all the protocols within those layers, not all of them, but all the necessary protocols within those layers. It's very important that we have a really clear understanding, a good grasp of what's happening inside these headers, inside these layers. Think of this as the learning networking more than a 16-year-old, because he tends to be your nemesis. The 16-year-old knows an awful lot about networking on a daily basis. So we need to know a bit more, and this is a great place to start. So we get down to layer 2, and you'll see there that the data packet, still here in the middle, has been shrouded by several headers, and each of these headers are relevant to each of the layers of the OSI model, and each contains sets of rules which have to be obeyed as that data packet moves from one host to another across the world. Finally, when it gets down to the physical layer, layer number 1, you'll see that a header is placed around, a frame is placed around all the headers. So that black frame frames it all together. Think of it as boxing it all up. And now the data packet is ready to be sent to the next host. So that data packet in the frame at the bottom right hand of your screen, that's the state it has to get in on your phone in order for it to be ready to move to the next. Okay, so now that we've got the header, the headers all, the data packet and all the headers and the frame all built around those headers, we're now able to move the data packet from one host to the next. And we'll do that through the physical layer. So in this case, the physical layer is the physical medium with which we're sending the data packet and all the headers across. We're going to draw a cable here. This will be either a fiber optic cable or it could be a copper cable. And by creating that cable or using the cable as an example, we are then going to send the data packet and all the headers from one host to the next. We're either doing that by electrical energy because we're using copper, or we're going to do that using light energy, in which case it's a fiber optic cable. Of course, there is a much more common method that we can then send the data packet, which isn't using a cable, but it would be by sending it over Wi-Fi through radio frequency. Either way, however we decide to send this data packet with all the necessary headers, we are moving that packet of data from one host to another. So arguably, the physical layer, you could say, is the most important layer of all of those in the OSI model, because it doesn't really matter how smart the software application engineers are to create the applications, or indeed how good the network engineering guys are. If that cable hasn't been terminated properly, or if indeed the Wi-Fi network hasn't been established correctly, that packet of data is going absolutely nowhere. So it's very important to bear in mind that all of these layers of the OSI are extremely important, but layer 1 extremely important due to the fact that it's carrying the data packet from one host to the next. So now that we've moved that data packet from one host to the next, what we can see here is the data packet moving back up the OSI model in quite the opposite way that it did before. The data packet will then be introduced to the next host. Now, if it was as simple as that, I would finish my presentation at this point. But of course it isn't, because you're not necessarily sending your data packet directly from one phone to another, or one phone to a server. There are lots and lots of hosts in the middle of that whole chain. So let's just take the data packet back to a layer 2 switch in this instance. Commonly where a Wi-Fi access point might be plugged into, and this of course is usually the host that lies between a Wi-Fi access point and your router. And what we're going to do now is just take a look at what happens when the data packet with all of its headers and the frame comes in at layer 1, at the physical layer. Because the layer 2 switch is very much what it means, it's only able to understand protocol and information at layer 2. It can't go any further than layer 2. Its job is to move packets of data around extremely quickly and extremely efficiently. So what happens here is that the data packet is moved up to layer 2 because the switch can understand what happens at layer 2. It's a layer 2 switch, but it's not going to go any further. So this switch, this layer 2 switch, is not capable of reading and understanding layer 3 protocols. So there's no point in sending it up to layer 3. There's nothing that this switch can do for that data packet at layer 3. But at layer 2, it will strip off the head, those layer 2 headers. And once it's done that, it repackages those layer 2 headers, and it will then be able to send this data packet on its way. But of course, what it's also doing then is it's making a note of everything it can read within those layer 2 headers. It's not touching the data packet, doesn't understand the data packet, it just understands the rules at layer 2. Where is it coming from? Where's it going to? So that it's able, this switch is able to expedite the transport of that switch, that data packet rather, from one host to the next, and when it comes back, it can send it back in the right direction. So here we go, it's repackaged layer 2's headers, it sends it back down to the physical layer and on its way. So that's an example of how the data packet, it moves from one host to another. The OSI 7-layer model is always prevalent in every single piece of networking equipment out there. However, some networking equipment will only read the headers up to a certain layer and then back down the other end, repackaging that header of information and sending it on its way. And just to draw this first educational webinar to a close, this is the OSI model in its full form. We can see, just to summarize, there's the user operating a network device at the top, and in order for that network device to communicate with other devices on a network, the data packet is given headers of information which contain protocols or rules from layers 7 down to 1, whereby it's then and only then able to move the data packet to the next host. And the next host, as we've seen, is able to deal with that information and push it on to the next host, and so on and so forth. Whereby, of course, when it gets to where it's needing to be, in this case, wherever Facebook servers are to give you the home page, the whole reversal process is brought back again. So in order to get that data packet back to your mobile device. And say we'll look at that in more detail with the face-to-face training, and we'll move that forward in the next webinar to give you an overview of those first few layers and what is actually contained within those headers. So I shall hand back over to Kerry now, who will summarize the webinar. Thank you for listening.
Thank you, Matt and Rob. This was a great webinar. Matt shared the basics of the OSI model, which is very important to understand for solutions being deployed over a network. As we mentioned at the start of the webinar, AV over IP is not an overly complicated solution, and ZeeVee offers solutions that were engineered to be deployed as simple as possible. If you're using ZeeVee as a standalone product, it's a virtually plug and play. If you're deploying over a client's network, then this basic IP knowledge is most helpful. To learn more about AV over IP, we encourage you to continue to watch our webinars, and we encourage you to attend our in-person training where you'll receive InfoComm RU credits upon completion. You can see our full training schedule at www.zeevee.com/training. Thank you again, Matt and Rob, for this webinar, and we look forward to hearing feedback from the attendees. Thank you.